Viscosity is a relationship between the shearing force acting on a fluid and the rate at which the fluid's flow accelerates. It is normally denoted by the Greek letter mu. In other words, viscosity is how thick the fluid is or how runny it is. The water on the left has a lower viscosity than the fluid on the right. This can be visualized by the fact that the water flows more freely than the fluid on the right. As you can see, the water deforms more readily than the fluid on the left on this vibrating table. A Newtonian fluid has a constant viscosity, whereas a non-Newtonian fluid has a variable viscosity. In this case, we are using a shear thickening fluid, which is a fluid that has an inverse relationship between the shearing force and the shear rate. This means that as the force acting on the fluid increases, the shear rate decreases. Therefore, the fluid appears to thicken as it is subjected to a force. In this video, we'll be using oobleck, which is comprised of cornstarch and water, as our shear thickening fluid. We will be exploring its reactions to various forces along with silly putty and water. See how the wrench sinks into the oobleck compared to the water. Observe carefully as the wrench hits the surface of the oobleck. The oobleck acts like a solid at first because of the high shearing stress applied from the impact, but it then sinks because the gravitational force of the wrench is much lower than the impact force. Silly putty is another non-Newtonian fluid. This one, however, requires a minimum shearing stress before it starts to flow. Here's a wrench hitting silly putty. Notice the force of the wrench is not enough to deform it. See how the silly putty forms a fracture in the slow motion video because it is a non-Newtonian viscoelastic shear thickening fluid. Notice how the oblique resists the change in shape during the initial punch, but then starts deforming like a liquid right after. If you thought that was cool, watch the next clips. Now we will subject the oblique to a 0.2 gram plastic BB shot from a propane-powered pistol. Observe the splintering of the oblique upon impact of the BB and how it reintegrates into the rest of the fluid. See how the water does not stop the BB nearly as much as the oblique. See how the BB punctures the paper normally. Now watch as the silly putty is shot and how it prevents the BB from puncturing the paper. Thanks for watching.